Okay, well, I think we can get started. So, hello everyone. My name is Roland Tink, and on behalf of the DECT Forum, I'd like to welcome you to this webinar today. It's one in a series that we started back in 2022 in April, where we first introduced DECT NR+. Then last year we had a whole series of webinars where we focused more on the applications and the features and benefits and the technology more in depth. And then April this year we had a webinar to talk about how to get started with developing DECT NR+ products using the SDKs from Nordic Semiconductor and Wirepas. And now in our journey, we have come to the point that we can present working products and solutions. So I'm very pleased that we will have a presentation today by Nathan Savage from Pentaforis and Joseph Wamicha from Sustain Group, both South African companies. We will talk about smart metering solutions for Africa and how they use DECT NR+ in their solutions. And then finally, I'd like to point out that we have a FAQ page on our website where you can find a lot of questions about DECT NR+, and we continue to enhance that. So with that, I hand over to Nathan and Joseph.
Thank you very much, Roel, for the introduction. It's a pleasure for us to be part of this webinar. My name is Nathan Savage. I am a consultant located in Cape Town, South Africa, and we assist companies and municipalities, businesses in the energy industry on their energy solutions. Part of that is their metering strategies and helping them with their technology development.
Thank you, everyone. Thank you, Roel, for the introduction. So my name is Joseph. I head up the Sustainable Energy Technologies team. I'm also an electrical engineer with a specialization in wireless networks. So we are part of the Sustainable Energy Group, and we are the arm of the company that builds the electronics. That's the modems and for communication, as well as the design of the PCBs and the manufacturing that we need for instrumentation of energy generation units, as well as metering. We also do monitoring for the company and for private utilities and public utilities. Part of the reason we looked at DECT NR and why it was interesting for us as a group was, number one, our roots are in Norway, and the Nordic Semiconductor has actively adopted DECT NR. So that was quite interesting for us as a group, and we're quite invested into it.
Thank you, Joseph. So let me head right into it. So I thought I'll start off with some humor. You guys can read through it. So this is the whole story around silver bullets, which is a magical weapon that's able to defeat werewolves. So they're asking them, I've got the silver bullet. He says, do you have a gun? Shoot him with a finger. So what am I actually getting into? I'm getting into that there are no magical solutions, right? I think there's technology that's fit for purpose. So what is the status quo currently on the African continent and in South Africa? The predominant technologies that's used in metering in Africa are both PLC, which is called power line carrier, and cellular. And I'll just give an overview on the left. It shows a typical PLC network where you have a distribution network, you have homes, you have meters within those homes, and you have the meters communicating over the physical power lines back to a data concentrator. And from that data concentrator, where all that information is collected, it's then sent over the cloud to whatever software or services the client may be delivering. Okay. On the typical cellular network, it behaves a little bit differently from a network perspective. You have the same network where you have meters within the homes, and each one of those meters will have a cellular modem in there, and that cellular modem would then communicate to a cellular base station, and from the cellular base station, that data then would be backhauled to the software or services that the client is using. If we look at what the status is in terms of metering technologies within on the continent, the predominant technology that's in use is prepayment metering, and prepayment metering has its benefits, and specifically in terms of your revenue collection side of it, whereby customers actually purchase energy before they use it. And that's similar to the concept within your cell phone technologies where you have prepaid cell phones. So basically you buy before you use. And that technology is quite predominantly used within South Africa and within the rest of the African continent as well. The other technology that is quite prevalent is also the concept of split metering. And what that actually means is that the metering unit itself is a separate entity to the keypad. And if you are using prepayment, the way the technology works, as in my picture on the left, is that when a consumer purchases credit, they will get issued a 20-digit PIN code, and that 20-digit PIN code will be a representation of the actual kilowatt hour that they've bought. And in order to input that amount onto the meter, they would then input that 20-digit PIN code onto the meter itself, and the meter would then accept that token. That's the name used, and that token then would be represented as kilowatt hour. So that's the typical type of metering technologies that's in use. And then if we look from an typical installation side of it, all right, what is the typical meter installations that we would find in the field or around with various customers, be it utilities, municipalities, or even private utilities? So you would have a typical installation which is pole mounted, as you can see my picture on the left here, and that's a group of meters which is DIN rail type connected meters installed on a pole, and that pole is then feeding those homes below, and in those homes are then the keypad, which the customer then doesn't have access to the meter directly, but they have access to the keypad. So the concept around that is to do with revenue protection, and from a revenue protection perspective, it's how does a utility or municipality actually manage their non-technical losses, which is a nice way of saying theft. So one of the methodologies used is that they go to split metering. So they actually install the meter on a pole that's out of the customer's access, and the only access that the customer has to the meter is actually through the CIU. Another typical installation is actually the picture on the right, which is a ground-mounted kiosk. So that's mounted on the ground and found as part of your street furniture. And you would also have a split meter installed in the kiosk. And from the kiosk to the home, you would then have the keypad. The third type of installation, it's then directly in the home, where the full meter, the keypad and the meter, it's one device, and it's installed within the customer's premises. So when it comes to the technology types that are out there, in terms of the cellular technologies and PLC technologies, I think they have their pros and cons. I mean, the good part of the technology is that PLC and cellular, it's widely adopted in the market. It's widely adopted on the continent. Those technologies are proven, and it's deployed in millions of devices, and the municipalities and the utilities that users are fairly familiar with it. And both technologies, they actually allow for automated transmission of metering data. What's not so good about those technologies is that like I showed in the previous slides, when it comes to the network side of it, if you're rolling out a cellular network in terms of your communication, each one of those cellular meters requires a SIM cards. And from a utility side, operationally, SIM cards are a nightmare to manage because they get lost, they get stolen by people using the data, as well as the data costs. That's actually part of the cellular solution, because what does data cost means? That means there are subscription fees that they have to pay monthly in order to maintain that communication and connectivity. The other issues that is often found is that there are black spot areas where there aren't actually any communication coverage because it's in a kind of a blind spot where there's no cellular. If we look on the PLC side, what is the challenges that utilities experience is that lots of utilities and municipalities suffer frequent power outages, and PLC communication, because it uses the physical power lines, doesn't really work well under those conditions. And if there is a power shortage, it takes a while for the network to then restart, and for nodes in the network, which could be a meter or concentrator, actually go missing in the network. One of the other issues around this is also when it comes to renewables, which is more and more a part of the grid, small scale embedded generation where they have rooftop solar, etc. This noise on the network often affects the PLC communication between the devices. Another aspect is that when it comes to the data concentrator, which is a part of the network, as I showed in one of the pictures, which is a collector, rolling out those networks, the cost in terms of the overall cost of the implementation to utilities and municipalities could be quite high as well. Given the issues that these technologies have, we went out and embarked on what options are actually out there in the market, right? What alternatives are there? And when looking at alternatives in the market, what we were trying to focus on was looking at something that was an open standard, looking at something that was easily scalable to millions of devices if need be, looking at a technology and solution that was adopted, looking at a resilient technology solution, using a different type of communication infrastructure. And in our research and looking at those different aspects, we then came across Wirepas, and that ticked all the boxes when coming to those type of requirements that we had. It's an open standard. It's adopted by NR+. It's in a license-free frequency band. It uses the 1.9 gigahertz frequency band. The Wirepas technology is well proven with deployments globally. It's being used globally on deployments across different continents, and the technology is proven. The SLA uptime, it's 99.9% as one of it. And in terms of scalability, to deploy a network, it's fairly straightforward and easy, and just depends on the physical number of gateways that you actually deploy. So there was a slide missing there, but just to kind of enhance off that is what type of network the typical Wirepas network infrastructure is like. So I explained what the PLC holds. I explained what the cellular holds, and this is a typical Wirepas network in the field. So each one of these nodes would have a network card within it, and these nodes will then all speak to one another, and that data is then moved from node to node until it reaches a gateway. And then from the gateway, it then will be backwalled via cellular, which would then go back to the head-end system or whatever piece of software that the utility has in play. So the benefit of this type of network is there is no physical power lines. We're using RF. The other benefit is that there's not any SIM cards in each device. we just have a SIM card or using cellular on the gateway and that backhauls. The other resilience is that as each node adds to the network, the more resilient the network actually becomes. So I'll just play a video that actually demonstrates how the technology works.
If you are into IoT, maybe you wonder why Wirepas is the best network. Well, here's how it works. Let's start with the gateway that has a mesh radio. A device pops up, not connected at first. It hears the gateway and makes a connection by itself. The device becomes a router. It spreads the news. Listen, I have a route to the gateway. As more devices pop up, some connect directly to the gateway, but most of them go through other devices. Every device is also a router. Every new device finds its own route completely autonomously and changes the route if needed. No need to plan or install routers. And the network grows simply by adding new devices, without any limits, infrastructure or wires. Because all devices, even the routers, can be battery operated. With Wirepas, data transmission is easy. One of the devices has a message to the gateway. It sends it through other devices. It finds the best route by itself. Other devices are sending messages to the gateway too. Every device can transmit to any device in the network. Device to device, device to group of devices, or device to all other devices. And if there is something to share, the gateway can reach any device at any time. It's simple to increase capacity in a Wirepas network. Just add more gateways. No configuration or recommissioning required. Anywhere you put it, the devices nearby reach out. And suddenly there are more ways out of the network and more capacity, making room to send lots more data. So what happens if a device is removed? No problem. The other devices automatically find the next one to connect. And if the connection is unstable, a device transmits again or finds a new route until the message is successfully transmitted. And if a gateway disappears, the devices reconnect to find another route. In a Wirepas network, devices always find a way to get messages delivered. Over time, there can be external interference from other radio equipment such as a mobile Wi-Fi hotspots. Once again, the devices automatically find interference-free radio channels. And only the devices interfere change channel, the remaining network stays unchanged. This also minimizes interference generated by Wirepas. Smart, right? You can't get better than that. Wirepas, very good IoT.